So now that we've done a deep dive on the injection unit, I thought I would draw your attention to the very front of the injection unit, and this is the nozzle. The nozzle is where we transition from the molding machine itself into the mold. So this is the section we're going to talk about today. So this is the nozzle tip. This is the interface between the injection molding machine and the mold back here. This section will move forward and actually engage into the mold right there. So this is that's where the sprue goes in, and this is the ball. Let's pull this out and take a little bit closer look. Now, if we take the mold out of the machine, we can see this a little bit better. So this area here is called the ball, and it's actually a concave, so it dips in there, and that is where the nozzle tip of the machine interfaces to the mold itself. This is also where the sprue begins. So your standard molding machine will come with a nozzle body assembly kind of like this, and this is all one piece. And what happens is inside of here there's a heater band that wraps around this to keep it warm, keep the plastic all melty and liquidy. So when you have to change this out, you have to take off that heater band, you have to disconnect the thermocouple and make sure you don't damage either of those. Then you have to unthread this, get a different one, put it in, and then put your thermocouple back in the heater band and hope all went well. And that's a pretty cumbersome process. I'm not a big fan of that. Instead, what we do is we change this out to a body with interchangeable nozzle tips. So your standard nozzle tip will look something like this. It's much smaller and you don't need a heater band on this. So it's very easy to change in and out anytime you need to. So with our nozzle tip, you can see how this interfaces right there. So this is where we transition between the machine over here and the mold here. Now, in the United States, it is customary for this diameter to be 1-inch sphere. Now, there are different ways to do it. There are flat interfaces, and there are, of course, metric designs, but in the United States, this is typically a 1-inch diameter. In some cases, you might have a very specific mold where you need a long nozzle tip. So sometimes that sprue is buried very deep inside the mold. That's way back there. Hard to even touch that thing. Now for something like that, you're going to need something like this. This is an extended nozzle tip, and it's required to get into those deeper mold designs. Now you might be asking yourself, why would we need all of these different nozzle tips? Well, one, if you transfer a tool from a foreign country like, let's say China, for example, chances are it's not going to have a 1-inch diameter ball. It's going to have some metric ball, or it's going to be a flat one. And in those cases, you have to change this out. You can't use your general purpose nozzle body for that because it's not going to fit and you're going to leak plastic everywhere and wreak all kinds of havoc. But there's more to it than even that. Your orifice diameter is very critical. So, for example, that right there, that white tip, is the plastic that's inside this nozzle tip. And that diameter is different than this diameter. Now, it may not look like much, but it is an important difference. Let's look at that real quick. Now, while the ball has some very consistent measurements, this hole in it, that orifice, is not consistent. Different molds will require a different orifice in their sprue. And that also means that you are required to have a different sized orifice in your nozzle. So let me show you what we're talking about here. So I'm going to draw the ball, and this is the whole sprue bushing here. Okay, and inside of this there is a little bit of a taper. So it's a little bit bigger on this end than it is on this end. And then the nozzle would set in there. So plastic is injected through here from the injection unit, and then it runs through your sprue bushing and into your part. So generally there's a runner kind of runs like this. So your material will come into here and then it will branch off through the mold. So this is your sprue, this is your runner. And if we take a real part and put it in there, my scale's a little off, but it would be, this is the runner. So this piece right here is the transition between the sprue and what's in the nozzle. So when it's being molded, it's actually inside of there. So it sits something like that. So when the mold opens up, it pulls this out of the sprue bushing, and then you eject your part. Now, what's important about this is each mold potentially has a different sized orifice here to determine a different size sprue. And that determines how fast the material flows into the mold, how uniformly it flows into the mold. It's also determined by the type of material that you have that you're working with, and how far the plastic has to travel from here all the way into the part to get to the part itself. So those are all factors that would determine this orifice size and this angle here on your sprue. So that's all determined by the part design. So what that means is you create the mold optimized for your part. And then you pick your nozzle that is most appropriate to match your optimized sprue. Now, a really important thing to keep in mind here is you can use kind of the wrong sized nozzle tip and you can still shoot a part. But if, and I'm just going to sketch the sprue here. So if your nozzle comes in here and it's the hole inside the nozzle is a little bit smaller than your sprue, then when this opens up, this will still pull. However, if you do something bad, like the ball comes around here, so this is the full nozzle tip. So if the hole is something like this inside your nozzle tip, then what you'll get is the plastic will fill all of this area, including into your sprue. So when you're working with this sort of design, this is a big problem because the plastic will actually hold this into the nozzle tip and it will prevent you from pulling your runner out of the machine. So you'll go to open this up and it will stick. And that sort of thing happens when you've got the wrong nozzle tip for this mold, or more specifically for this sprue. Now I also mentioned that different materials will require some different dimensions. So if we are going to look at this nozzle tip, some of the designs for this are a little bit unique. So we're going to okay, so your typical orifice through here is just kind of a straight line. That's your normal orifice design, and this can be bigger or smaller, but that's basically what it looks like. If you're working with certain materials, like nylon in particular, requires kind of a different thing. So we will put what's called a reverse taper into this. So it actually looks kind of like that, and then it will spread out this way. So that's kind of a nylon tip design. Now the reason we have this reverse taper here is because what we're trying to encourage is the material to break here, there. So this material is still molten, but it's freezing, and then when it's time to pull this open, it will break back at this point rather than up here at this point. You have to kind of encourage certain materials to behave that way. So not only do you have a whole variety of different orifice sizes to deal with, but you also have varieties of geometry, like for example, your straight bore or your reverse taper. These are all things you have to factor in when you're dealing with nozzle tip selection. So as you can tell, things are a lot more complicated than they first appear. I had a wise man tell me one time that the only things in life that are simple are the things we know nothing about. And actually, they only appear simple because we know nothing about them. Well, that's all I've got for you today. But make sure you come back and check out the channel later because we're working on some really cool things. Don't forget to like and subscribe so you can get all our latest content. And remember, go out there and do something cool today.